going mostly to be using an example of AWS because that is the cloud platform that I have interacted with mostly. So if you log into AWS, you will see a lot of services. You will see services like EC2, you will see services like IAM, Lambda, VPC, and suddenly it feels impossible. You don't know which service to start with and which service to end with. So, but here's the truth. Cloud is not hundreds of disconnected services. The truth is infrastructure is organized into categories. So the mistake that most beginners make is trying to memorize tools, as I said earlier. Now, for example, let's say because here we are people from different sections of the world. We have people from East Africa, West Africa, and also people who are overseas. So imagine you are trying to learn a city by memorizing every building. Is that possible? Most of the times it's not possible because yes, you will learn the building, but you may not know which road connects to that building. So the simple way of learning a city is you try to learn the roads. You know that from moving from point A or moving from a certain building to another building, you use a certain road called this and that. So you maybe learn the roads, you learn the neighborhoods around the city or in the city, and also how places connect, right? That is the same thing when it comes to cloud. So that is what we are going to be doing today. So let's now start from the beginning. Let's understand first what is cloud. So when people hear cloud, most of the times they imagine something floating in the sky. But that is not actually the case, right? So cloud is actually very simple. It simply means that you are using computing resources that over the internet, right? So that means instead of buying or managing your own servers, you use infrastructure that someone else manages. Just like the diagram that I have provided here, you log into your computer and you try to access cloud resources through the internet. That is cloud. Now, so cloud is not basically magic. It's just cloud is real computers that are being hosted or managed by by another person. So you access it when you need it. So then what exactly is cloud computing? We have the model of, there is a way people like, before cloud computing was introduced, there is a way people used to manage their resources. And some companies also, even at this time, they are trying to manage resources traditionally. And traditionally, this means that as a company, you buy your own servers, you install them, you maintain them, you upgrade them. What does this mean? This means that it takes a lot of money to buy your own servers, employ workers to maintain them and upgrade them all the time. Then it also takes time and it also takes space. That is the traditional way. But now when it comes to cloud computing, you just rent what you need, okay? So you need storage, you rent storage. You need databases, you use managed databases. You need computing power, you just rent the computing, okay? So cloud gives you flexibility. So you consume infrastructure the same way you consume electricity. I believe in most of our countries, we have companies that provide electricity, right? For example, in Kenya, we have one. We have several, but the major one is KPLC, Kenya Power and Lighting Company. So, and one of the ways of using power is through prepaid method. You just use a method, you just pay. Okay, so you just pay. Maybe, for example, you have power has gone off at night. So you just logging into the system, you have maybe 100 shillings, and that is what you can afford at that time. You use that 100 shillings to buy some tokens. Maybe it will get 2, 3, or even five tokens, okay? So that is how cloud works. You pay for what you use. You pay as you go. So cloud services are delivered in the same way. Now let's move also to, I hope up to there we are clear. No one is lost. Okay. Let's look at now the cloud service models. Thank you for your response. There are 3 common cloud service models. Cloud service models is the way cloud services are packaged and divided between what you manage and what the cloud provider manages. But how? Okay. And there are 3 service models. We have software as a service, we have platform as a service, and we have infrastructure as a service. Now, in simple way, think of it like renting a place to live, okay? So, for software as a service, for example, you go to a hotel, you rent a hotel, okay? So almost everything is handled for you. You book a hotel, you find there is soap, there is maybe meals are also provided at the same place. You don't have to do anything. Your work is just to get into the hotel and take the rest that you need, maybe sleep and everything, okay? So everything is provided. You have also room service. That is software, that is just like software as a service. Or maybe now when it comes to applications, the way you use Gmail, you don't have to manage anything. For you, you just want to access your Gmail inbox, read your emails, send emails. You don't have to do anything. Now, platform as a service is just like renting a furnished apartment, just like Airbnb. Airbnb, if you're renting it for a period of like 1 month, maybe there's some things that you will be doing for yourself. Let's say like cooking. You may decide to cook for yourself. You may call maybe sometimes room service, or maybe you tell them to come and clean your place, but there are services that you have to do for yourself. That is platform as a service. Now, when we move to infrastructure as a service, it's just like now you want to be independent. You want to do everything for yourself. You go, you buy a land, and you start building from scratch your home, okay? So you manage almost everything there. Or maybe renting a house, a space to live, but you come with your furniture and everything. That's where you live. So you are managing everything for yourself. That is infrastructure as a service. Are we okay up to that? I can see some questions, but I can't see them clearly because the way is sharing the screen.
No, there is no question for now.
Okay,
if not, okay. There is one. Wait, there is one, but I don't know if it's a question. But how would they? Wow, it's not written in good. How would they? Wow, Suba Sanget, can you please tell me the question because I cannot read it? Like, how would they can build servers like that, but we can't? It's not proper English. I don't know if I can really read it.
Okay, someone else is saying that I explain
yes.
Infrastructure as a service again.
Yes.
So the analogy that I was using, I was saying that you try to imagine you are trying to rent a place to live, okay? So IaaS is renting like a house. Most of us, the way you go somewhere, you rent a house or maybe an apartment. But this apartment is completely empty. So you start from scratch. You buy your own furniture, you buy kitchen utensils, you buy everything. You're doing everything for yourself, but this house belongs to a landlord or a landlady. It's not your house, but you are the one who is coming with your own things. That is infrastructure as a service. Yes. Melaku Betty, is that clear? We don't want to leave anybody behind. Okay, thank you so much for confirmation. So if that is clear, then let's look at our next section, where we are going to look at regions. That is the real concept around cloud computing. As we said earlier, cloud feels virtual, but actually it is physical. It's someone else's services of computers that you are using. So these computers, or they are called data centers, they are hosted somewhere in regions. For example, AWS, it has very many regions across the world. And we have one in Africa, that is in Cape Town, South Africa. That is a region. That is an AWS region. And in this region, they have what we call availability zones. So in Cape Town, we have things like different to small sections of, maybe in Cape Town, maybe we have sub-cities that are, I don't know the names around Cape Town, but I can try use Nairobi. Nairobi is also like a region, okay? If AWS decides to come and have a region here in Nairobi, they may put one availability zone in let's say Muthaiga. They put another one in CBD. That is an availability zone, and every availability zone, that is a data center. Okay. So and so, as you have said, each availability zone contains a physical infrastructure. So these are the actual buildings with servers. So why multiple zones? Multiple zones are for reliability. That is, if one location fails, and the other locations will continue serving users. It's always advisable, if you are building your infrastructure, you host it in two availability zones. Actually, like maybe two in two availability zones, so that if something happens to one availability zone A, and maybe you have hosted your resources in availability zone A and C. If something happens in availability zone A, your users will continue being served because availability zone C is still available. That is what we call resilience in cloud computing. So now that we understand what is cloud, let's move to the 5 building blocks of cloud computing. And as I said earlier, this does not necessarily say, or maybe we are not just relying on AWS. It is the same concept if you go to Azure, the same concept if you go to GCP. The 5 building blocks. This is what you need to understand first, so that you can be able to move. You will be able to understand any kind of infrastructure if you understand this. So this slide actually is maybe the most important slide of the entire session, because once you understand the 5 building blocks, everything else becomes easier. So we start with compute. Compute is where we run workloads, okay? This is where applications do work. Maybe the front end, okay? So for example, if you log into an application, what you see is hosted in a compute, okay? Like virtual machines, EC2. We can say like EC2. So then we have storage, the second building block, which is storage. For storage, maybe files, images, videos, user data, all of them, they need somewhere to reside. Maybe an S3 bucket or RDS or even databases like RDS. Then we have networking. Networking allows systems to communicate. How do they communicate? We look into details on each and every building block. Then we have identity and access. That is, it answers the question of who are you and what can you access. Example is IAM. Then we have observability. This answers the question of how do we know if the system is really working or if the system is even healthy. And that is where now the logs, the metrics, and alerts come in. Now, let me say, for example, we have a shopping mall. The workers in that shopping mall are our compute block, because they're the ones who are doing everything. They're the ones who are serving people. If you walk into a mall, and in this mall you have a supermarket in a mall. If you walk into this supermarket and maybe you want to look for sugar, you will walk to a worker in the supermarket and ask them in which shelf or in which aisle will you find sugar. They will give you the directions. When you are going to pay, you'll find the cashiers there. They are the ones they will serve you. So all these workers, they are like the compute. They are the ones who are running the workload. Then we have inside the mall, we have warehouses, right? Maybe where people are keeping their goods and everything. Now that is the storage block. Then we have the pads. Maybe moving from, we all know that a mall holds so many shops, or even we have shops, we have hospitals, we have eating restaurants, we have all kind of businesses happen in a mall, okay? So moving from one store to another, how they connect, the roads, that is the networking. Now, identity. Look at the security guards. Before you get into a mall, especially here in Kenya, I don't know if in other countries it's that way. Before you get into a mall, they have to frisk you, they have to look into your bag, they have to know who are you, okay? And if your intentions are good as you walk into the mall, because mostly because of the cases that we used to have of terrorist attacks in malls, okay? So security was a bit beefed up. So you meet those security guards, those are the identity and access, IAM. Then we move to observability. Around the mall, we have CCTV cameras inside and outside. So if maybe an incident, a robbery happens in the mall, what do? The first question will be, do you have CCTV cameras? They will say yes. Then they go to the CCTV, they try to retrieve. At that time, what time was it? It was 3 p.m. Let's check that section. Give me the footage of that section. The footage will be retrieved and they'll be able to know maybe this person was captured, this was their face. And they'll be able to publish, maybe asking someone who knows this kind of a person, they can provide information. That is all those 5 building blocks. That is how they work. So these 5 blocks are what we will use now to understand the architecture. Now let's look at each building block and bring them together into a real application. Okay, then we have compute. Let's start with compute. That is the first building block. Compute is where work happens. We have already said that, where the applications run and where processing happens and where business logic lives. So in AWS, we said an example of compute is EC2. We have used workers in a shopping mall as an example. So EC2 stands for Elastic Compute Cloud. So just ignore the name and think of it simply as a computer in the cloud. That is like the laptop in front of you, but it's in the cloud. Someone else's computer, as we said. Now, let me ask a question. If EC2 suddenly stops, what happens? We can give our answers in the chat box in the next 30 seconds as we move on. If EC2 stops, what happens? Let me see your answers. Downtime in business, yes. We are 50 people in the session. Downtime and less redundancy in another availability zone. Yes, thank you, George. Another person. We are all here to learn. There is no wrong answer. There is no wrong answer. I'm also learning. I can see there was a question, how are companies like AWS and Azure able to build servers like that while we can't? For me, a simple answer is they have the resources. They have the time, they have the money, that is, to put up such kind of resources, and they have the capacity to hire workers to maintain them. For me, I think it's just, if there's somebody else with a different answer, for me, I think is they have the resources. A common person like me, I may not be able to run such kind of resources because I don't have the resources of the money and even the workforce to do the same. Applications become unreachable. Thank you. Yes, thank you. Thank you so much. Thank you, Alex. Thank you, Vivian. Thank you, George. Thank you for everyone who has given us an answer. So, exactly that is what will happen. The application stops. And as George said, and also Alex said, unless you have provided redundancy through another availability zone. So if an EC2 of availability zone A stops, and maybe you had availability zone A and C will continue, or even B. If you have A and B will continue serving traffic. So if our cloud system is a shopping mall, compute is the workers inside the stores doing the actual work. So if workers stop working, everything else stops. So, but applications do not work alone, right? Applications do not work alone. They need other things. Other things like what? Applications need memory. And that's how we move to our second building block. So, which is storage. Applications, for example, a user logs into a system. Their logins data, that is the user, their username, their password, it needs somewhere to reside, okay? For example, if you're using an application like Instagram, all the photos that you upload, they need somewhere to reside, okay? So that's where now we come to storage. But not all storage is not the same. We have storage for structured data and storage for unstructured data. So structured data is like users, orders, posts. Like you can be able to, the data is somehow, for example, if you have a user, a password, and their username, that is a structured data. But data like files, images, videos, documents, that is unstructured data. And that's where we use S3, Simple Storage Service, S3. But for RDS, we store the structured data. And we have here an analogy, like, so yeah, S3 is just like a warehouse. You put your boxes, okay? Boxes that maybe contains clothes, maybe shoes. But for the RDS, it's your records office. For example, where you keep your invoices, records for every purchase that has happened, the transactions, that's it, okay? So, RDS, yeah, as we have said, we have this structured and unstructured. Then, for example, as I have given Instagram, your profile photo that you're using for Instagram, should that photo, where should that photo reside? Is it in an S3 bucket or RDS? Where should it reside? Guys, please, where should the photo reside? S3 bucket or RDS? S3, yes, thank you, Brian, thank you, Eve, thank you, Samantha. Yes, thank you. The actual image will live in S3, but the image information, like the metadata, will go to RDS. The metadata is, we all know the metadata of a photo. For example, which maybe our photos that we take with our phones, they have metadata like the time the photo was taken and where the photo was taken. Some photos, they have location where you took the photo and even what kind of a phone you used. That is the metadata. So that will reside in RDS, but the actual photo will reside in S3. And then also now we move to our third block, that is networking. Networking answers the question of how do systems communicate. VPC, in AWS, VPC gives systems a private environment. So think of VPC as the neighborhood where our cloud resources live. But there's another important question I have to ask you guys. Who is allowed into the neighborhood? You are in your neighborhood, but who is allowed there? That's where IAM, that is Identity and Access Management, comes in. IAM answers, who are you, as you said earlier, what can you access, and what actions are allowed. For example, if you are employed in a company and you are a developer or an administrator, you have different rights, okay? So for example, if you are a new developer, they may decide to create a user, IAM user, and in the policy, you'll be given the rights of read only. Because you are new, and maybe they want you maybe in a period of 1 month to learn how the system works. So maybe you can be given the read only access. You can only read, but you cannot make any changes, okay? Maybe now after 6 months, they have trusted you and maybe now you have been given work. They can edit and give you the access of read and write, meaning you can read and you can actually make changes to the system. Now, if you are a user for maybe, for example, I am a user in that application, I cannot, for example, access my data, okay? In for example, Instagram, I don't know even where my photos are unless I know where, maybe for example, I may only know maybe Instagram, they use a certain cloud platform, but I may not know where that data is. Because my interest is just maybe to log in, interact with the application, and that's it. So that's it about the networking and identity access management. Now let's move on to observability before we go on to the architecture diagram. We see how they interact. So now we have observability. Now this is most of the underrated concepts in cloud. Why? Because people mostly remember the compute, they remember the storage, they remember networking, they will remember identity and access. But most of the times, observability is also as important as the rest of the building blocks. Why? Because it helps us to understand how our system behaves. Just like we said, it's just like a CCTV in a mall. Using observability will help us to understand if our application is healthy, and how do we know users are seeing errors, or how do we know the database became slow? A simple answer is we will just do observation. Observability helps us to understand what is happening inside the system using things like logs, metrics, and alerts. For example, if traffic spikes, a failure happens, maybe there's a performance issue, that is, you will get an alert. Maybe a certain container has failed at 2 a.m. You will get an alert, okay? And for example, if something has happened in your system, the way we have also people who are working. You wake up one morning and your system is not functioning as it is supposed to do, okay? Somebody, for example, let's say a bank. In a bank, we have a system like that handles the money transactions and everything, okay? So maybe a certain worker who is maybe a developer logged into the system and they made some changes. Some of these changes may be they interfered with how maybe the load balancer works, okay? So in the morning, or maybe like 2 days later, the bank realizes the money transactions, it's not working the same it's supposed to do. Maybe, for example, someone sends money. Yes, Tara?
It's time for Q&A now. It's like 41. We have 5 minutes left, and then we have the Q&A.
Okay, it's okay. I'll be done in the next 3 to 5 minutes.
Perfect.
Okay. So as I was explaining, for example, there is a way you know how your system behaves. And then you wake up one morning, it's not serving the kind of transactions the way it does. What will you do? Maybe you'll go into logs. You check at maybe when did the system start misbehaving? Maybe it was at on Friday at 5 p.m. What happened? Who logged into the system? And what changes did they make? That is the work of observability. Okay? So I hope up to there we are okay. Then we have an architectural diagram. I will stop sharing this so that I can share the architectural diagram as we wind up. Thank you for... And let me share again. Can you all see the architectural diagram? Okay, so this is just a simplified cloud architecture. So everything starts here from the user. The user makes a request through the internet. Okay, so maybe they open an application, they log in, maybe they want to upload something or even search something. So the request is sent through the internet. So, and it reaches AWS, then into VPC. As we said, VPC is our neighborhood, okay? So inside the request comes to the compute, EC2, okay? So EC2 receives the request. Now, maybe the request was to access username and password, okay? So EC2 needs that information from RDS, where we have the structured data. It sends the request to RDS. So it talks to storage, RDS. Now, for the files, for example, if maybe you want to access a certain video, that request will go to S3. Now, how does everything, EC2 combines everything. So if the request is sent and it's received and the photo or the video is there, the response comes back through the EC2. The response does not travel from S3 to the user. It will come back through EC2. Then from EC2 back to the user through the internet. Okay? So here we have the compute, we have the storage, we have the identity. Identity we said is who are you, what can you access, or what are you trying to do. Observability is how everything is working, okay? So user sends the request, compute queries the data in RDS, or maybe accesses files in S3, identity and access secures everything. Then observability monitors all, then the response returns to the user through the EC2, okay? That's it about the architectural diagram. Then, but now I'll ask a question for you guys. I want to, in the next 2 minutes, we will be done. I want us to become cloud architects for just 2 minutes. We are going to try and build Instagram. So, if now you are building Instagram, my first question is, where does the application logic run? Where will it run? Which building block? Where does the application logic run? Guys, thank you. No, Brian said storage, EC2, 640, EC2. Thank you for your answers. Yes. The logic we run in EC2, that is, EC2 is a compute building, it's a compute block. Then for the question 2, where do the photos live? Where will our photos go? Remember, we are building Instagram. Where will our photos live? Yes, S3, storage, yes, S3. Thank you for your answers, storage, yes. Yes, thank you. Thank you so much. Now for question 3, how do services communicate? The services that you are building, how will they communicate? VPC, thank you. Afari, thank you. Thank you, Lagat, thank you, Monene. Thank you so much. For question 4, who controls access? Who will control the access? IAM, thank you, Monene, thank you, Mina, thank you, Isaiah. Thank you so much. Now, our last question. How do we know if something breaks? How will we know if something breaks in a piece of our system that we're trying to build, that is the Instagram? How will we know when something breaks? CloudWatch, yes. Thank you, Jeff Coril. Thank you, Afari. Thank you, Mina, CloudWatch. Yes. Thank you, observability. Thank you so much. That means that we have really understood, and thank you for interacting. We just designed a cloud architecture. Now, our final part now of the session before we go to Q&A is so today we have just moved from confusion, I hope so, for everyone who is here. And now we have a mental model, just like the way I said. I would really love you for maybe after this, maybe if you're given an architecture, you can really understand how the information flows or how the application or maybe the infrastructure is built around. So we moved from cloud, we looked at service models, we looked at regions, the 5 building blocks, and now the architecture. So cloud becomes easier when you stop memorizing services and you start understanding relationships. So thank you for spending your time with me today, and I hope one thing changed today. I really hope something changed today, even if you work with just 1 point or 2. And I hope after this, cloud should no longer feel impossible. You don't need to know every service. You just need to understand how systems fit together. And that understanding grows over time. Even if you find yourself after 2 months, you don't really get the concepts, give yourself some grace, because there is no time you will ever become an expert in these systems. You are always in a learning continuously. And that understanding, maybe you take 1 month, others take 6 months, others over the years. And yeah, take grace with your time, with yourself, that is. And I would love to hear now your questions. Thank you so much. Remember, if you don't ask me questions, I will ask the questions.
I think you can ask the questions. Maybe we don't have questions because they are so great. So then maybe I can challenge everyone here, which no, it wouldn't be good for all of you, right? So
Okay, what about attaching the EBS to the EC2, and what role would our RBS instance play in the private subnet? Okay, Alex, I think, how will I answer this? Different systems work differently. It just depends with what you are working with. For today, you are just learning the basics, and as we said, there are a lot of services, and EBS is mostly attached to EC2, maybe for snapshots and everything, okay, for storage. So I think it just needs from here, you need to understand, because even compute, we have also containers, we have serverless like Lambda. It just depends on what you are working on, okay, and maybe what your system you are working on. If you need a fully managed service, or maybe you need to manage the services yourself, it just depends. I think I have answered you. It depends on the kind of system you are building that will determine. But that will determine what you will use for storage. Okay. Sometimes you will need S3. Other times you will not need S3. You will need EBS files like the one you have said it for EC2. Okay. But I think you may also need RDS at the same time. I think I have answered you. It just depends with what you are working on. The important thing is just understand how those services connect to each other and how they talk to each other and what does what. Thank you. So I'll ask you guys one question, or maybe two, before the session ends. I'll ask, what surprised you most today? Were you surprised? Or maybe we talked about something that you know. What surprised you most today in this session? I said if you don't ask me questions, I will ask. Learning concept instead of tools. Thank you, Maurice. Anyone else? Then if you are not surprised, I will ask, if you are told to explain cloud to a friend now, what would you say? Eve, how easy you made it seem. Thank you, Eve, and you're welcome. How simple the structures are. Thank you, Osho. Maybe I'll give, for maybe the next 1 minute, I'll give maybe two people, Tarak, if you may allow me, to give at least two people who can tell us if they had to explain cloud to a friend, what would they say? Two people. I said there is no wrong answer, and we are all here to learn. At least two people who can tell us if they were to explain to a friend what cloud is, what would you say? To do so using someone's computer to do a task. Thank you, Monene. Neema Kageni, what would you say? Virtual servers in the cloud where you run your workload. Thank you, Alex. Cloud is basically renting a bigger computing power to those who need scaling access. Thank you, Osho. Thank you. I will end up my session at that point, and I'll just leave you with this line. Cloud architecture is simply the art of making systems work together. Thank you so much, and thank you, Tarak and Ozi Unara, for giving me an opportunity
I think
to
it was
spearhead
great.
this session. Thank you so much.
Yes, I spent 5 years working in cloud, and to be honest, I learned a lot. I don't know if it was only for beginners, but I learned a lot. So it was very nice. Thank you so much.
Thank you.
Thank you. Have a nice one, everyone. You will find the link to our WhatsApp group in the comments, and you will find a recording as well in the university as well. So thank you, and see you. I think see you on Saturday when she can come again. She is going to come again. Don't worry. She's an amazing person. I really appreciate her, and she's working a lot with us. She will create other events and article as well. And to be honest, she's a great person, and I really appreciate her.
Thank you so much.
You're welcome. So thank you. I need to jump to my session, but it was a great one. Thank you so much. She's a great teacher. Yes. Okay. See you. Bye.
Bye.